This mode makes it possible to study cell mechanisms behind generation of action biopotentials in various sections of the conduction path. The mode is accessible when the heart is selected from the main menu. Having initiated the mode, a user will observe the interactive dynamic graph showing the propagation of the excitation wave through the pathways of the heart. Yellow squares stand for unexcited cells in corresponding sections of the conduction path, red squares for excited ones, and pale red squares for those in the refractory phase. Digits within squares show time elapsed since excitation emerged in the sinus node in milliseconds. Most accurate readings are provided upon completion of the first excitation cycle after this mode has been selected. The number of squares is proportional to the cell count in the given node as compared to the sinus node. That's why the bundle of His has 5 squares and the left ventricle has 12 of them. A user can manually slow these processes down to step-by-step performance. A left click on a square in any section of the conduction path is all a user needs to select a particular cell within a related group. Action biopotential generation in the cell selected will be shown in real-time scale. Let's take a sinus node cell as an example. In the real-time mode, the membrane channels open and close. Ion concentrations on the 2 sides of the membrane alter. Electric potentials change. ATP-driven potassium-sodium pumps work. All quantitative indices of the cell's ionic content, performance of sodium, potassium, and calcium pumps, as well as time intervals, are in full correspondence with respective values for a living cell. Identity between parameters of impulses generated and what has been provided in scientific literature is a good proof thereof. In a like way, one can see how separate cells of any other group are working. Let's have a look at a left ventricle cell. This working cell is contracting. The contraction mechanism is shown in the real-time mode in the window of a power stroke of actin and myosin filaments. With the help of interactive levers, a user can alter in the real-time scale the state of ion channels, thus changing parameters of the action biopotential generated. The parameters changed can be saved by a click on the Save button. All the cells in the related group will now be working with those new parameters. That is how various pathologies can be modeled in this mode. The heart and ECG modes will reflect such changes automatically. Such interventions are like open heart surgery in real life, which is why running of other modes will be suspended when this mode is engaged.